All right. So today we're going to be taking a look at evaluating trig functions for some higher angles using what's called reference angles. So here I have a kind of definition, a layout of what a reference angle is. So if we have some angle theta in standard position, then its reference angle is the acute angle theta with an apostrophe after it. We call that theta prime, which is formed by the terminal side of our angle and the x-axis. All right, so there's a bunch of words there. They can be kind of confusing, so let me show you what I mean. So a reference angle is an easier angle that we can use to help us solve trig functions. And it works nicely because, as we saw briefly when we first started looking at sine and cosine, is that they're periodic, right? So the answers repeat themselves. So, you know, the sine of 0 is the same as the sine of 360, which is the same as sine of 180. So we can use kind of concepts like that to simplify angles to make them easier for us to look at and to evaluate. Also, because we have our three main angles, 30 degrees, 45 degrees, and 60 degrees, if we can boil down our functions to those three, to one of those three, then things become really easy for us, and we can use, you know, the unit circle or special right triangles or whatever we have. So if I have an angle that's in the first quadrant, so remember too, we went over a couple rules. With the quadrants and the signs being positive and negative, right? So I gave that to you Friday last week, right? So we're going to use that in conjunction with what we're doing. So if we're in the first quadrant, we don't use a reference angle, right? It's already between 0 and 90 degrees. There's nothing for us to do. That's as simple as it can get. If I am in the second quadrant, so there's my initial side, and now I have some terminal side over here, right? And this is our quadrant 2. So here is my original angle, theta. What the reference angle is, the reference angle is the angle that's made between the x-axis going to the other side. So this over here is going to be my theta prime. Okay, this part over here is my reference angle. Now, it's nice because of the way, you know, trigonometry works. If I evaluated sine, cosine, or tangent of this angle, it's going to get me the sine, cosine, and tangent of this angle. But again, we have to be careful. We're going to get a positive answer, but if we're doing sine, cosine, or tangent, we have to apply these rules. All right, so if I took the cosine of anything in the second quadrant, that answer is automatically negative. If I took the tangent of anything in the second quadrant, again, that answer is automatically negative. All right, so here's our reference angle. We can get this reference angle by subtracting our original angle from 180 degrees. Okay, or if we're talking about radians, from pi. All right, and I'll go over examples once we get through all the formal stuff. All right, if we are in quadrant 3. All right, here would be my large angle. Now again, be careful. My reference angle is always made by the terminal side and the x-axis. So I'm not drawing my reference angle down here. My reference angle is just going to be from this line to our terminal side. All right, so here our reference angle is there. And now what we do is we swap this, and to find the reference angle, I'm going to do my original angle minus 180 degrees, or my original angle minus pi. All right, and that's because now we're greater than, and we don't want to deal with negative angles. The whole reason we're finding reference angles is to have an angle that's in between 0 and 90 degrees, right? Because those are more simple. And then our last one is when we're in the fourth quadrant. All right, so here we would have a very large angle that would be greater than 270 degrees. But now my reference angle, I can find that easily between here and my x-axis there. All right, so now it's a little different. Instead of subtracting from 180, we're going to subtract from 360. Or 2 pi. And so there we have all the situations and how to find our reference angle. Any questions so far before we get into some examples? I'm always spelling reference wrong, so if you just see it. All right, so we'll do a few. No, I don't want to do that. All right, so here we have 4 different scenarios, 4 different angles. We're going to find the reference angle for all of them. So the first thing you want to do is you want to figure out what quadrant you're in order to figure out which one of these rules you're going to use. All right, so the first one is 300 degrees. So if we go back to our quadrant rules, okay, 300 degrees would be in our fourth quadrant, okay, between 270 and 360. All right. So if you'd like, okay, label it or, mark it somewhere just to give you reference, right? We're in quadrant 4. So I'm going to use my fourth quadrant reference angle formula, right? So my reference angle is going to be 360 degrees minus what my current angle is, 300 degrees. So my reference angle is 60 degrees. That's straightforward. And finding sine cosine of tangent of 60 degrees is a little more straightforward than finding the sine cosine tangent of 300 degrees. Right? And if we get to some examples today, though, we have to be careful. Right? So if I find the sine cosine tangent of 300 degrees, right, like I just said, I can find the sine cosine tangent of 60. But the problem with this is the sine cosine tangent of 60 will give me all positive answers. But because I'm in quadrant 4, Well, here my y values are negative. My x values are still positive, but my y values are negative. So that's where we have to reference this chart. Okay, so whatever the sine of 60, I'm going to make that negative for the sine of 300. The cosine of 60 and the cosine of 300 are both going to be positive, and whatever the cosine and the tangent of 60 is, I have to make that negative for the tangent of 300. All right, I'll go back to that again if we have more time at the end of class. All right, so let's take a look at a radian one. So here I have 5 pi over 4. All right, well, I don't have my thing. I don't have my list, right? So if anything, right, you can always reference the unit circle. Let's see, let's pull that up. All right, so we look at the unit circle. I'm looking for 5 pi over 4, and that's over here in my third quadrant. Okay, so 5 pi over 4 is quadrant 3. So I'm going to use this equation here because I'm using radians, right? I have to subtract by pi. So I'm just going to put quadrant 3. So my reference angle will be, now my angle comes first because I want to make sure it's positive. So I have 5 pi over 4. So I'm subtracting pi, but I need a common denominator. So I'm going to subtract by 4 pi over 4, right? So I multiplied numerator and denominator by 4. So here my reference angle is pi over 4. Right, so I could use pi over 4 to calculate the sine, cosine, tangent of that. But again, I'd have to apply my signs depending on what I'm doing, sine, cosine, tangent. All right, for the fourth one, we have a negative angle. Now that poses a slight problem. I don't have any rules for negative angles. I don't know what quadrant it is in. And if I did find what quadrant it was in, with negative 135, if I subtracted it, I'd be adding. So I'd have a larger angle than 180. That defeats the purpose. If I subtract from it, I end up with an even larger negative number, greater than 90. So again, that defeats the purpose. So here, first we have to find a coterminal angle. All right, so remember to do that, we can either add or subtract 360. In this case, we're going to add 360, so we end up with a positive number. So 135 plus 360 gets us 225 degrees. Okay, so if you're given something that you're unsure of, okay, always add or subtract 360 or 2 pi to find that coterminal angle. Again, here we're in quadrant 3, so I apply the same rule here, but now I'm going to do 225 minus 180. Right, and when we subtract that, we get 45 degrees. Okay, so this next one I threw in there because it's a little bit of a curveball. Oops, this is supposed to be D. 2.3. Now, it's not in degrees. I don't see a degree sign there. But I don't have pi. So, because it doesn't have the degree sign, okay, this is in radians. Now, normally, we like our radians to have pi, so when we subtract, we keep that pi there. If you don't see pi in the original angle, pi will not be in your reference angle. All right. So what we do, well, we have to figure out what quadrant this is in. Well, we know that pi is 3.14. Well, this is less than 3.14. Pi over half, right, which is 90 degrees. Pi divided by 2 is going to be 1.57. So that 2.3 goes in between 1.57 and 3.14. So this is going to be in quadrant 2. So I go to my quadrant 2 rule. Is it in quadrant 2? Yeah. So I'm going to do pi minus that. So my reference angle is going to be pi minus 2.3. And now I would actually just do that. I would do pi minus 2.3. So we're going to say about 0.8416, we'll say. And I'm going to put radians at the end just to show that we're talking about radians. All right, so sorry, this is a little jumbled right now. But there we go. All right, so most of the time you'll be dealing with pretty straightforward. If it's degrees, it's very straightforward. But just be careful if you see something like that. Any questions so far? All right, so I also have this that I found that actually takes it a step further and helps us solve. All right, so here, this is what we're looking at, right? This is any angle in the coordinate plane. So here with the green, you can drag the point M around, right? And it shows you your reference, your angle here. If you go past 90 degrees, you can click on this little check mark, this box, and it shows you your reference angle. Right? So here, at an angle of 135.8, or let me try to get that close. There we go. At a reference angle of 135, I'm sorry, at our original angle of 135, we get a reference angle of 45. Right? And here, it gives you the values as they are, right? Everything there. Right, so you can move that around and you can see how the reference angle behaves with your original angle. All right, so you're going to have some homework tonight. You're just going to find the reference angles of some angles I give you. You can use this if you want. This does not give you radians. So if there are any radian questions, you do have to do the math for that on your own. All right, and then tomorrow we'll take a look at actually evaluating our trig functions, so finding the sine, cosine, and tangent. All right, guys, so keep a lookout for that assignment, and I will see everybody tomorrow.